Hello, this is Erhan Gengic. We are a group in Turkey. We deal with treatment of wastewater by electrochemical treatment systems. In this study, we use a carbon felt material as a cathode, and then we modified it by thermal processes for increasing the effective of electrode in electrophantom systems. Before sharing our results, please let me give you some information about electrophantom processes. Electrophantom processes is depend on classic phantom processes, in which we use peroxide as a oxidizing agents, iron as a catalyst. At the end of reaction, we obtained hydroxyl radicals. As you know, hydroxyl radicals is a very powerful agent, and it reacts with pollutants. Thus, we obtained high removal efficiency in wastewater treatment. A classic phantom process is a very effective one. However, there are some difficulties in this process, such as storage and operational cost of chemicals. So, we produce peroxide at cathode by reduction of oxygen. You can see the systematic presentation of electrophantom process in figure. Please let me give you a brief about how we made in this study. We bought carbon felt in Turkey market. Then we used it as a cathode, and we try to determine the effect of pH, potential, and iron concentration on peroxide production rate and dye removal efficiency. Then we determine the optimum operational parameters. In the second stage of our study, we modified the raw carbon felt by thermal processes, and we obtained four different cathodes by this method. Then we try to find the optimum pH, potential, and iron concentration. You can see our electrophantom process. Actually, it is a very basic one. Uh, we use, as I mentioned before, we use carbon felt as cathode electrode. We use a metal composites anode, and we use caramel electrode as a reference electrode. These electrodes, caramel electrodes, anodes, and cathodes, were connected to potentiostats. In this study, we use acid orange 7 as a model dye, which is a azodise. We filled the reactor with aqueous solution of acid orange 7. Then we supplied samples by a pump, and we sent the sample to spectrophotometer by this pump. In addition, we took some samples into reactor for measurement of total organic carbon. Yes, what we made in this study, we buy carbon felt carbon material, and we cut it with a total area of 150 square centimeters. Then we kept it in an acetone for washing process. for a part of washing process. Then we dried it in an oven and we use it as raw carbon felt. Uh, After that, we placed into a furnace this raw carbon felt. We placed into a furnace this raw carbon felt, and furnace was purged with nitrogen. Then we increased the temperature under flowing nitrogen up to desired value. Afterwards, the process was continued with nitrogen gas for 1 hour. Then the samples were cooled, cooled. Yes, you can see our first results in figure. In this section, we try to find the optimum pH value for peroxide production and TOC and dye removal efficiencies. As you see, we obtained the maximum peroxide production and maximum removal efficiency at pH of 3. The second section of our studies, in second section of our studies, we try to find the optimum cathodic potential for these electrodes. As you see, we obtained a maximum peroxide production rate at 1.8 volt, 0.8 volt, and the removal efficiency is enough high at this potential. The next stage or studies is about iron concentration to determination of optimum iron concentration. As I mentioned before, we used iron as a catalyst. However, we know that when we increased the iron concentration, some parasitic reaction realized, so the removal efficiency decreased. Yes, after determination of optimum pH, cathodic potential, and iron concentration with raw carbon felt, we start to our second stage of study. In this stage, a new stage of our study. In this stage, we modified raw carbon material at different uh, temperatures. As you see, we obtained the maximum peroxide and dye removal efficiency at 900 Celsius degree. After that, we use this electrode, which is modified at 900 Celsius degree, for determination of optimum iron electrolyte iron concentration, electrolyte concentration at cathodic potential. As you see, 1.3 millimolar iron concentration is the best. As a similar, we obtained is the best. On the other hand, we obtained the best removal efficiency with 50 millimolar of electrolyte concentration. Please let me remind you, we use sodium sulfite as an electrolyte in this study. Finally, we obtained the maximum removal efficiency at 1.8 volt. However, the removal efficiency which are obtained in 0.8 volt is very similar. So we accepted 1.8 volt as a optimum potential. Because, as you know, when we increase the cathodic potential, when we increase the cathodic potential, when we increase the cathodic potential, the cost of operation increased. Yes, you can see the optimum experimental conditions which we are obtained. Finally, we deal with Fenton process. We buy carbon felt material and we use it as cathode. We try to increase the effectiveness of this cathode by thermal modification, and indeed we obtained it. We found that the electrode which is modified 900 Celsius degree is the best one. Thank you very much for your attention. If you have any question, I will be glad to answer it. Yes.